All right, folks, here is a problem that we dealt with on Tuesday. It took us basically the whole class to really to do this problem, but this time it won't take as long because we're going to dive right into it. So you see here, this is what the goal here, of course, is to rewrite it and simplify it if possible. And you see how this is a sine of something plus something, right? So we're adding two things. All right, so you're going to use, if you look on your identities page, you should be looking for an identity that is the sine of a sum, the sine of something plus something. So you find that right here. So you have alpha times cosine beta plus cosine alpha sine beta. Okay, so what that means is this right here, this is your alpha, and this is your beta. Okay, and this is not plus or minus one another. That's going to confuse somebody. All right, now, what do we do? So, let's plug in our alpha and beta just like that. So we'll have, this is equal to, according to my identity here, sine of the first part, arcsin of x. And I'm not worried yet about the meaning of this. We'll explain that in a minute. For now, we're just putting it in, all right? So don't worry just yet. Beta, I should have put arccos. I should have done that. All right. Arccosine of x plus cosine arcsine times sine arc cosine. All right. Lovely. Now, how do we do this? So I'm going to go to another page for a moment just to think about sine of arc sine. Let's just think about this for a minute. What is sine of arc sine? This right here is an angle. This is the sine of an angle. All right. So we just think about a triangle here. Okay. And let's say this is the angle we're talking about. This is the angle that has the sine that is x. All right. In other words, if we say that theta equals the arcsine of x, by definition, that means that the sine of theta equals x, because these are inverses, right? See how whatever I put into this function and whatever I get out of this function, these are reversed in the other function, right? Here, theta goes in, x comes out. Here, x goes in, theta comes out. So you should get used to writing one statement and the other together. And if you can do that, it's going to help you with this. So what we've done is we've taken theta, we've drawn it so that we want it to equal arcsine of x. And the way we do that is to make sure that the other statement is true. We make sure that the sine of this angle actually equals x. And as you know, the sine of an angle equals opposite over hypotenuse, right? So if we can make the opposite, which is this side, and the hypotenuse, which is this side, something so that they divide to make x, then we'll be in business. So what we did in class was we made this x, we made this 1, x over 1 is x. The sine of this angle now equals x, which means that the arcsine of x will equal this angle. So this right here is now representing what I have right here. Okay. Now this should go fairly quickly for this first part. In other words, what now is the sine of this angle? Well, we already said about 20 times, right? The sine of this angle is x over 1. So this right here is equal to x over 1, which is just x. And I know I can make that look more respectable. All right, this is just equal to x. Now that, of course, is going to be important on this page, because look what we have right here. Sine of You got sine of arcsine of x right there. Now we also see down here sine of arccosine of x and cosine of arcsine of x. All right, so let's think about for a moment. Let's think about, just for a moment, cosine of arcsine of x. And I want to think about this because, excuse me, we already have arcsine of x. Remember, this theta is equal to the arcsine of x. So this right here is referring to the exact same angle, right, that this is referring to. This angle and this angle, they are the same. So what is the cosine? Oh man, got a little time left here. What is the cosine of this angle? Okay, so cosine, we know, cosine of an angle is equal to the adjacent side divided by the hypotenuse. Well, we know our hypotenuse, we made it 1. We made our opposite side x. We want to know what is that side so that we can get our cosine, so that we know the value of this. So this is where the Pythagorean theorem comes into play. Let's get another color for our Pythagorean theorem. Let's say that this side is called A, and the Pythagorean theorem, of course, goes like that. So we'll say that a squared plus our other side, x squared, is equal to this side squared. 1 squared is just equal to 1, so I just write 1. Okay, now don't forget, we're solving for a. So because we're solving for a, I'm going to get a by itself. And so a is going to be the square root of 1 minus x squared. So that's what I have right here. And when I do the cosine, which is adjacent over hypotenuse, this is the adjacent side. This divided by 1 is my value for this. So I should have done this in black as well, just to be really consistent and impressive. All right, so we'll do this divided by 1. There you are. So I've got this part, I've got this part. It's almost all I need to do, where am I? Here I am. It's almost all I need to do this. Okay, so now let's plug in. Sine of arcsine of x, we figured that out. It equals x. Okay, I think that's the last time the bell's going to interrupt us. Sine of arcsine of x equals x. I plug that in here. Cosine of arccosine. Well, for the exact same reason, that's going to equal x, right? Cosine of arccosine, sine of arcsine. It's a function and its inverse. It's a function and its inverse. They undo each other, and I just get x. So this is multiplication. I want to bring the operation down. I'll bring this operation down. That's plus. Cosine of arcsine. We figured that out right here. It's root 1 minus x squared. 1 minus x squared, the quantity under a square root sign, over 1. All right. And I don't need the 1 over 1, right? I don't need to write that over 1. So I won't bother with that here. So it's, so this. And finally, I have sine of arccosine of x. Well, what you're going to find is that's the exact same thing. Because if I wanted to make my angle, because right now my angle is the arcsine of x. What if I want to make my angle, the arccosine of x? Well, then the cosine of the angle has to equal x, and then I have to do adjacent over hypotenuse is x, and so x is here, 1's here. And so it's exactly like this, because if I do the Pythagorean theorem again, I'm going to get the same thing for the other side. And now, of course, I want the sine. I want the sine of arccosine of x. Well, the sine of this angle right here is just the opposite over the hypotenuse. And so I get the same thing, square root of 1 minus x squared over 1. It's the same thing again. And I multiply. So, I'm about ready to wind this up. x times x is x squared. This times itself is just the radicand itself because it's a square root times itself, so I just get the radicand. So I have x squared plus 1 minus x squared. These make 0. I just have a nice 1. Okay? And here's what we pointed out in class. This is the coolest thing about this, is that we can now say, since our original expression is equal to 1, right? That means that our argument here, the sign of this is equal to 1, well, that means that this right here must be pi over 2. The sign of pi over 2 is equal to 1. And sure, there's more than one angle, right? Because there are coterminal angles that also have a sign of 1. But this is the only one that it could be because it's made up of an arcsin and an arccos. Arcsin doesn't just give you any angle. Remember, arcsin only gives you angles between negative pi over 2 and pi over 2. And our cosine only gives you angles between 0 and pi. So the only way for us to take something from here and something from there and add them together and get something that's going to have a sign of 1 is if that thing is pi over 2, right? Nothing else is going to do it. So that's the only thing that's going to work. So we know our angle is pi over 2. Pi over 2 is also known as 90 degrees, right? Well, if we think back to our triangles that we made here, this angle was the arcsine of x. And if you look at how symmetric this is the arccosine of x, which means arccosine of x is right here. In fact, we could even call them, just like on the other page, why bring in other Greek letters? We could say this guy right here is your alpha, and this one right here is your beta. Alpha plus beta, just like we're showing here, alpha plus beta's got to equal pi over 2, 90 degrees. Well, of course it does, because look, they're the two complementary angles in a right triangle. Oh my God. Complementary angles in a right triangle add up to be 90 degrees. The sign will be 1.